Assalamualaikum warahmatullahi wabarakatuh and hi. Today, my team will present Mat183 calculus assignment, which is the topic is application of differentiation, analysis of function 1 and 2. My team name is algebraic team. So meet my team, which is me, Nurhana Alisa binti Iskandar, matrix ID 2023683696, program code Mat183, CDCS 112, course group 1A. The second member is Nur Adana Atira binti Muhammad Farizi, matrix ID 2023620352, program code Mat183, course code CDCS 112, and group course 1A. The third member is Nur Aimi Afrika binti Azman, matrix ID 2023876342, program code Mat183, course code CDCS 112, and course group 1A. So I will present about the introduction of analysis function. What is analysis function? Analysis function, in the context of calculus, the analysis of function involves studying the properties and behavior of mathematical functions using calculus techniques. Here are some key aspects of the analysis functions in calculus, which is first limits, derivatives, integrals, critical points, continuity, concavity, and convexity, curve sketching, and optimization.
As for polynomial function graph, we can use the function given as an example. First, we need to find the x-intercept and y-intercept. As for x-intercept, we need to set the function to be equal to 0, and we will get x equal to 0 and x equal to -3. For y-intercept, we need to replace x with 0 and we will get y equal to 0. Then, we need to find the first derivative, which is f prime x, and we will get 3x squared plus 6x. The next step is we need to set the first derivative function to 0 to find the critical value. Then we will get x equal to 0 and x equal to -2. Then we need to make a first derivative table which conclude the interval, which is -∞, -2, -2, 0, 0, infinity, and test value if the f prime x in the f prime x, so we can know the sign. As you can see on the table, if the sign shows positive, the interval will be on the increasing interval. If it's more than 1, you need to put union between them. For decreasing interval, there's only one, which is -2, 0. Next step is to find extremum point. How we gonna do it? We need to substitute the critical value in the first function. For x -2, we will get 4, which means the max point is -2, 4. For x equal to 0, the outcome will be 0, and the minimum point is 0, 0. Step 7 is to find second derivative, which is 6x plus 6, and let it be equal to 0 to get the inflection value. The inflection value will be negative. Step 10 is to make second derivative table. It's same like the first derivative table, but the test value need to be substituted in f prime prime x. If the sign shows negative, the graph will concave down, and if positive, the graph will concave up. The last step is to determine the inflection point by substitute x equal to -1 to first function, and we will get 2. Put all the points that we have to a graph, and this is what we got.
So we move to the rational function. First, we need to find an asymptote. An asymptote is a straight line that a graph approaches without touching. In rational function, they have two asymptotes, which is vertical asymptote and horizontal asymptote. For vertical asymptote, let the denominator of a rational function equal to 0 and solve it. Then find its analysis by approaching the values from the left and right hand side. For horizontal asymptote, find the limit of fx when x approach plus minus infinity. Divide the numerator and denominator with the highest degree of x in denominator. Here an example for a rational function. Given a function fx equal to negative x over 1 minus x plus, first we need to find the x and y-intercept. For x-intercept, just take the equation equal to 0. Then we will get 4 over 5 for x-intercept. For y-intercept, just substitute the x value and we will get 4. We need to find the vertical asymptote by let 1 minus x equal to 0, then x equal to 1. Then find the analysis by approaching the value. For horizontal asymptote, we will divide the limit with the highest degree of x in denominator. Cancel out and substitute, we will get y equal to 5. Determine the intervals where the function increasing or decreasing, concave up or concave down. Last step, we need to sketch the graph of fx by using all the information that we get. Then determine the intervals where the function increasing or decreasing, concave up or concave down. Last step, we need to sketch the graph of fx by using all the information that we get. The conclusion is it takes a methodical approach and a firm grasp of calculus concept to solve application differentiation difficulties, particularly associated rates problem. Students can successfully determine the rates of change of value numbers in real-world situations by segmenting the problem into smaller sections, identifying the pertinent variable, and applying the chain rule. Utilizing these tools and working through related rates problems will help you improve your ability to solve application differentiation questions and build your confidence in using calculus in practical situations.
The references that we use to do this Calculus Mat183 assignment is Calculus 1 Revision Guide 2023-2024 by Teo Hin Kin and Suzanawati Abu Hassan. Thank you.